what exactly is the time and space complexity, how you are going to calculate this time and space complexity. Okay, short forms, not in-depth discussion of that we'll see it in our further sessions. Got it? So generally, a short forms, how to calculate. If I give a code snippet, how can you calculate the time and space complexity for that? I had explained in the yesterday session. Got it? So, and in our today's session, I'll give you some more examples on this time and space complexity. And then I'll give you an introduction to the data structures. What are the different type of data structures that we have? And we'll go for the next very important concept, recursion. In each and every demo session, I am taking a different topic, okay, and I'm explaining everything to you. So today my topic is what? I'll give you 3 or 4 examples on this time and space complexity, and immediately I'll go for the data structures and introduction to data structures. What are the different type of data structures that we have? That just introduction doesn't take much time. It will take just 10 minutes of time, because next after demo sessions, we are going to discuss about everything in a very clear manner. Got it? Then I'll start a very important concept in interviews, that is a recursion concept today. Got it? Sorry. Next, again, tomorrow and day after tomorrow, we don't have any sessions. When the demos are going on that weekend, we don't have any sessions on Saturday and Sunday. Okay. So next week onwards, Monday to Saturday, we have sessions. Sunday holiday. Okay. Monday to Saturday, 8 to 9:30, we have a session. Got it? And up to 9:15 or 9:20, we'll take the session. Another 10 minutes, we'll leave it for you people to clarify all your doubts if you have any. Otherwise, we'll continue the session. If you don't have any doubts to ask, then we'll continue the session from 8 o'clock to till 9:30. Okay. So first 2 months, we are concentrating on entire syllabus and the programs, everything. Last 1 month, we are concentrating on the competitive coding platforms, problem solving, right? Almost 100 to 150 programs, we are going to solve it, which are there in Lead Code and HackerRank, especially in Lead Code and HackerRank. If any important programs are there in other coding platforms also, that will pick it up and will practice. Okay. This is what our schedule for entire data structures course. Got it? If you want, you can please go through the videos of 2 demo sessions so that you will get an idea. Got it? Fine. Now, so I think yesterday what we have discussed, 1 minute. So yesterday we discussed about programming. What exactly is the programming? Data structures plus algorithms. We can call it as a programming. What is a data structure? It is nothing but how you are organizing your data so that it can be accessed in a very efficient manner. Okay. So algorithm means what? It is nothing but a finite number of steps that you are following to solve a particular problem. If you have a problem, if you want to solve that problem, you'll follow some finite number of steps that we will call it as an algorithm. Okay. So we can write this algorithm in 2 ways. One is by using normal, simple, plain English, and another one is a pseudocode. But in our data structures concept, if you are writing algorithms, right, you are not going to use normal, simple English. You are going to use the pseudocode concept. Okay. By using pseudocode, I mean in pseudocode format, no, you are going to write all the algorithms. Am I clear? Yes. So this is a recap of yesterday's session. Just 5 minutes give me. I'll just recap it and then I'll go for the today topic. So writing see, for every problem, there are multiple solutions. Yes or no? So we can write many algorithms for a single problem. Got it? So, but writing an algorithm is not a matter here. So writing the space and time efficient algorithm plays a very important role in the software industry. Got it or not? How you are going to analyze the performance of an algorithm? How can you say that this algorithm is good, this algorithm is bad, like that? See, we have some, factors that will affect on the, performance of an algorithm. Okay. So the most important 2 factors that will impact on the performance of an algorithm is time and space complexity. Okay. So coming to the time complexity, what I explained yesterday, how much time an algorithm takes to produce the desired output. how much time it is taking, how much memory space it is occupying or consuming to produce the given output. Understand or not? Okay. Next step. So I said no, you can write an algorithm in two ways. One is using simple English like this, or else by using the pseudocode. Okay, this is nothing but pseudocode is nothing but here you are not going to follow any of the programming language syntax. Yes, you're not following any programming language syntax, just you are writing like this. That is your wish. You can use this arrow symbol like this, or else you can go for the normal equal symbol also. Understand or not? Informal program description that does not contain any program syntax is nothing but C, pseudocode. Got it? Along with that, see how I said how we are going to analyze the performance of an algorithm using time and space complexity, I said, right? But there are so many factors available like machine architecture, processor, execution type and all. But we are not going to consider all those things here. I'm just taking the given input as a consideration, and based on that only I'm calculating the time and space complexity. But actually saying these many factors will be there to impact on the time complexity and space complexity. Got it? Understand? So okay, fine. So we got it. Okay, to analyze the performance of an algorithm, we should find out the time and space. But see, everywhere, everyone is, I mean, everyone wants to find the performance of an algorithm, right? Using this time and space complexity. If everyone uses their own methodologies or notations to represent this, it doesn't look good, right? That's why the scientist has provided a unified notation for that. That is big O notation. Got it. So here by using this big O notation, we are going to represent the time and space complexity. Got it. So for that, I have calculated yesterday. This is a swap function. Got it. You know, we have written a swap function here, right? Yes. So first the A value, you are storing it into the temp variable. B value, whenever you store this A value into the temp variable, you are assigning this B value to A and temp value to B, isn't it? So how can you calculate? Say, let us assume, like I am telling you, we are not going in depth discussion about this time complexity in a very short form. If you go for the interview, if you get any of the code snippet to calculate the time and space complexity, you don't go and you don't apply a big formulas there to calculate that. Yes or no? So just by seeing the code itself, you should be in a position to tell the time and space complexity. So that is what the reason I'm explaining in this way. Got it or not? Not more than that. We'll discuss more about this in the further sessions. Got it? Fine. So here the thing is what, let us assume like every statement occupies 1 unit of time and every statement of every variable occupies 1 unit of memory. Okay, I am assuming like that. Please consider this point. Okay, so here we have three statements, right? 1 plus 1 plus 1. So obviously 3. This will occupies 1 unit of time. This will occupies 1 unit of time, and this will occupies 1 unit of time. So total 3, which is a constant. So that's why it is known as a constant time algorithm. So to represent this constant time algorithm in the big O notation, we have O of 1. Okay, how can you represent the constant time? Using this O of 1. Next, how to calculate the space complexity? How many variables are here? 3 variables, A, B, and temp. A will occupy 1 unit of memory. Let us assume like that. B will occupy 1 unit of memory and temp will occupy 1 unit of memory. So total 3. So 3 is again a constant, okay, which is used to represent what? Which is used to represent a constant time. Understand or not? So space complexity is also O of 1, big O of 1. So O of 1 represents the, the constant time algorithms. Okay, time and space complexity of that is constant. That means for any value of A and B, it is going to occupy the O of 1 as a space and time complexity. Got it. Next. Yesterday I wrote this one also. This another code snippet also I wrote, isn't it? Here I have taken into product of intent. Okay. I've taken declaration of 2 variables and I'm calculating the product value here, and I'm finally returning the product variable here. Okay, fine. Now tell me the time and space complexity here. Yesterday I said, right, listen, every statement occupies 1 unit of memory, sorry, 1 unit of time That is what our assumption is, yes or no? So that's why I have taken like this one. And actually, please make a note of this. This loop will be repeated for n times for true, one time for false. Yes or no? Say example, if I give n as 10, right? N as 10, right? So this loop will be repeated for 10 times true. 11th time it fails, no. So, but that is also one iteration only, right? Got my point or not? Because it fails, it doesn't enter inside the for loop. Because it fails, understand my point or not? So 1 less than or equals to 10, true. 2 less than or equals to 10, true. Like that, the loop is repeated for 10 times. I plus plus I becomes 11. 11 less than or equals to 10, false. That means the loop repeated, but it doesn't enter inside the loop, inside the body of the loop. Why? Because it failed. Got my point or not? You should not say that this loop will be repeated for n times. So n times true, one time false. N times true, one time false. So n plus 1, you write it. Now, this inside statement is there. No, product is equals to product into I. This statement will be executed for how many times? Only n times. Because n plus 1th time it failed. No, that means what? It doesn't enter inside this loop. It doesn't enter inside that loop. Yes or no? So that means this statement is executed for n times. And written statement will occupy 1 unit of time. Let us assume like that. So 2n plus 3. This is a polynomial expression. Yes or no? 2n plus 3 is the polynomial expression. We'll take the largest exponent. That is the degree of the polynomial expression as the time complexity here. Okay. So what is the largest exponent? N to the power of 1. N to the power of 1. Yes or no? So the time complexity is O of n. The time complexity is in the big O notation. We will represent like this, big O of n. So why space complexity is O of 1 here? Why space complexity is O of 1? Why? Because here n variable is there, 1 unit of memory. I variable is there, 1 unit of memory. Prod variable is there, 1 unit of memory. So total how many variables? 3, no. So 3 is a constant, right? That's why it occupies constant time. The space complexity, O of 1. For any value of n, the space complexity is always 1, O of 1 only, because you require only these 3 variables. That's enough, right? Yes or no? Are you clear? Yes. So this is the code snippet that we have explained. Got it? So if you get any doubt, you can please type it in the chat box also. I will see and I'll reply for that. Okay, fine. So I am taking one more code snippet here. Okay. So let me take one more code snippet. What I'm going to do here is I'm going to write the same for loop. Okay. What I will do. Okay, done. Just okay. I wrote like this, and now what I am doing is I'm writing one more for loop. Sorry, one more for loop here. I is equals to 1. Okay, or else you can take I is equals to 1 only. You can take it. It's not an issue at all. Or else you can take it as J also. That is your wish. Yeah, I'll do one thing here. See, the largest exponent is what there actually will take the largest exponent of the polynomial expression. That means that is the degree of the polynomial expression, right? That we are taking it as the time complexity there. Prakash will explain very clearly about that, okay, in the further sessions. Got it? Actually, here in this 2n plus 3 is the polynomial expression, right? So in this expression, these are the short forms. That's what I'm telling you. Okay. So in this expression, largest exponent is what here? N to the power of 1, right? Yes or no? That will becomes the degree of the polynomial expression. Yes or no? How can you calculate the degree of the polynomial expression? So whichever is the largest exponent present in that polynomial expression, that we are calling it as a degree of the polynomial expression. Yes or no? That we are taking it as a time complexity here. Okay. That we are taking it as a time complexity here. Got it? Now, so let me finish it off and then I'll go for the next one. J less than or equals to N. Is it clear? Yes. So the highest degree that I am considering it as a time complexity there. Okay. N to the power of 1, right? That is the degree, right? That I am considering it as a time complexity there. O of N. Okay. Here in this case, see here, there is no power, right? This is a constant, right? That's why I'm considering in big O notation, constant time algorithm will be represented, constant space or constant time algorithm will be represented with big O of 1. That is a notation that we are using there. Okay, fine. So sum is equals to sum plus j, you can write it. Simply I'm writing like this. Okay, and then written here what you can written product or you can written sum. Anything is fine. Okay, simply I am writing a product only, or I can written sum also. That is your wish. Anything you can write it. Okay. So just put it like this.
So
Okay.
sorry,
And
sorry,
here,
sorry to interrupt you. You would be going in detail with all these notations, right?
yeah.
Will you explain what are these different types of notations?
Yes. Actually, yesterday I had just given an introduction for that. Okay. So big O notation. So we will discuss more about that in the further sessions. This is nothing but which is used, this notation is used to describe the efficiency of an algorithm. Got it? So actually we require a unified notation for representing this time and space complexity. That's why they have introduced this big O, big omega, and big theta notations. Got it? So these are all the common notations that we will use it. I mean, for representing the time and space complexity, we'll be using these very commonly used. O of 1, that is a constant. O of n, that is a linear, we can call it as. O of n square, quadratic. O of logarithmic, O of log n. O of n cube, cubic. Okay. O of 2 to the power of n. This is exponential. So these are the common big O notations that you are going to use it for representing the time and space complexity. Got it? So for that, I'm giving you a small examples. So we'll discuss it. It is not yet completed. We'll discuss more about this in the further sessions. Okay. Am I clear?
Yeah, thank you. Thank you.
Yeah. Fine. So here, when you see here, right? So I'm declaring 2 more variables here. Okay. So let me take 2 more variables. So here sum 0, you can take it, and j, you can take it. Got it. So let's take this code snippet. Okay. Let's take this code snippet. Now I'll ask you to find the time and space complexity for this. Got my point or not? I'll ask you to find the time and space complexity. Okay. Got it. So tell me now, based on our formula that what we have discussed till now, right? Okay. Just a short forms we have discussed, right? So by using that, can you please tell me what is the time and space complexity it will take? Yes, please.
O of n.
Yes. Yes. Yeah, someone message. We'll see the message. 1 minute. Time is O of n. Okay, fine. Listen. I'll tell you. Okay. Here one point you'll make a note. Okay. So say example, our assumption. Our assumption is what? So this entire thing will take it as one unit of time. Exactly, Mohan. Correct. And the above one also, I don't see your exact name, but it is O of n. Yes, right. So here our assumption is what? Every statement occupies 1 unit of time and 1 unit of space. Okay. So take this first statement. That is what this int I comma prod 1 sum 0 j. This will occupies 1 unit. Okay. Then plus this for loop. This for loop is there. Now first one for I is equals to 1, I less than or equals to n, I plus plus. This loop is there, right? This loop is repeated for how many times? N times true plus n plus 1th time fail. Total this loop repeats for n plus 1 times. Everyone will say that n times only, but that is wrong. N times it is true. N plus 1th time, another one more time it will repeat. That time it will fails. So n plus 1 only you should consider here. Okay, now fine. Then next plus. Inside this loop, one statement is there. No, product is equals to product into I. So that statement repeats for how many times? That statement repeats for n times only. Because n plus 1th time this loop fails. So the control never comes inside this loop. So this statement not executed. So only n times. That is what I mentioned there. Plus, again you wrote one more for loop. Again you wrote one more for loop. So this loop repeats for how many times now? This loop also repeats for n plus 1. N plus 1 because n times true. N plus 1th time it fails. N plus 1 times the loop gets repeated. Okay, next time it fails. No, n times true ma, written. And next one time it fails. Okay, done, written. Now, inside the loop, sum is equals to sum plus j is there, right? That statement is repeated for how many times? N times. The statement is repeated for n times. Okay, n plus 1 time, it doesn't enter inside the loop, right? Because it fails. Never enters inside the loop, it will comes outside. Written prod is there. No, that one occupies 1 unit of time. So total how much? 4n plus 4. Yes or no? 4n plus 4. 1, 2, 3, 4. 4n plus 4. Okay. This is a polynomial expression. Yes or no? This is a polynomial expression. The highest degree will be considered as the largest exponent will be considered as the degree of the polynomial expression, that we are considering it as the time complexity here. Yes or no? Here largest degree is what? N to the power of 1. Here largest degree is what? N to the power of 1. That's why we are considering O of n as the time complexity. O of n as the time complexity. Got it? Next, space complexity. Okay, space complexity. This is perfectly right. Got it or not? So this is so. See, immediately, okay, you should answer. Got it? So I'll tell you. I'll tell you once I complete this and then I'll explain you. S of x, space complexity. How many variables you are using here? N is one variable which occupies 1 unit of memory. I one variable, prod one variable. Then what next? This one, sum one variable. You can take the same I variable here also in this loop. I have taken separately, but instead of taking madam memory waste, right? Why are you taking another variable? Yes, of course, you can take the same I variable here also in the next for loop. Nothing problem. I had taken j, but instead of that, we can take I only. Got it or not? So totally how many variables are there? 5 variables are there. That's enough, right? Every variable occupies 1 unit of memory. So total what? 5, which is a constant, right? Which is a constant. That's why it occupies what? O of 1 space complexity. Okay, O of 1 space complexity. That means from this, what you have understood, having a separate loop like this doesn't make any major impact on the time complexity. Okay, so if an algorithm has n separate loops, then the loop which takes largest time will be the time complexity of the algorithm. Whichever the loop takes largest time, right? Okay, that will be the time complexity of the algorithm. Is it clear? Is it clear? Yes, fine. So now I'll tell you one example. Madam, you are telling all these by just assumptions, but that is perfectly right. Got it. These are the short forms to find out the time and space complexities of the algorithms. If you get it in the interviews, by seeing itself, you can tell immediately. Yes or no? Okay, O of n time complexity, O of 1 space complexity, like that. Understand or not? Say example, I'll tell you one example for this. Okay. Have you heard about the ones complement? Yes, ones complement of say example, I have one variable a is equals to I'll tell you 20. Okay, and I just want to calculate the ones complement of a. I just want to calculate the ones complement of a. Got it? Okay, so tell me how to calculate the ones complement of a. Ones complement means what? Negation. Ones complement means negation. Ones becomes zeros, zeros becomes ones. Yes or no? So now what you have to do, how to calculate this ones complement? You should convert this 20 into binary format, represent it in 16-bit or 32-bit format, convert all the zeros into ones and ones into zeros, so that the most significant digit is earlier for 20 binary number, the most significant digit is 1. Okay, so next, whenever you do this ones complement, I mean negation means zeros becomes ones and ones becomes zeros, right? By that time the most significant digit becomes a 1. So if it is 0, it is a positive number. If it is 1, it is a negative number. So you will get a negative number, but that is your answer for ones complement. But actually, in the computer memory, the negative numbers will not be stored directly. It will be stored in the form of 2's complement. Okay, you got the output as negative number, but negative numbers will not be stored directly internally in the computer memory. It will be stored in the form of 2's complement. Then how can you find out the 2's complement? First, for that result, whatever you got it here, you find the 1's complement, then add 1 so that you will get the 2's complement. That will becomes your result, which is this much of lengthy process. Can you do this in the interview? Can the interviewer gives this much of time to calculate this and tell the answer to you? No, right? He don't give this much of time to you, right? Yes, actually, this is the so this is the procedure actually. Say you should convert this 20 into binary format, then represent that number in in 16-bit or 32-bit format or 64-bit format. Then convert all the ones to zeros and zeros to ones, because it is a negation. So whenever you convert ones to zeros and zeros to ones, here for this 20, the most significant digit, okay, this one is the most significant digit, this side. Got it or not? So this most significant digit is 0 here because it is a positive number. Whenever you convert ones becomes zeros, zeros becomes ones, right? By the time this most significant digit becomes 1. Whenever it becomes 1, you will consider that it is a negative number. So your answer is a negative number. You got a negative number as your answer. Understand or not? As your answer. So but this negative number will not be stored into the computer memory directly. That is a rule actually. Got it? Negative number will not be stored directly in the computer memory. It will be stored in the form of a 2's complement. So for this, you should find out the 2's complement. Yes. So how to find out? For this negative number, again you calculate the 1's complement. Okay, and then you add 1. Then you will get the 2's complement. Yes, this is the actual procedure which will take minimum 5 to 10 minutes of time to do this. Yes, he don't give this much of time. No, I will tell you a short form. So if any number he provides, forget about the number. One's complement, if he asks, bitwise one's complement, simply one's complement of A is 20 is the number. Now that is a positive number. Negate it. Add 1. Minus 21 is the answer. Madam, okay, I agree with your formula, but if it consists of minus 34, what is the ones complement of this one, madam? Very simple. Minus 34, right? Negate it. Means it will become plus. Decrement it. 33. Understand? This is the short form. In this way only, I am telling you the short forms for this. Got my point or not? Understand? So this is a short form. Just you negate it, add 1. If it is a negative number, just you negate it. Negate it means what? This is a negative number already, minus 34. Okay, when you negate it will become positive. Decrement it. Because it is a negative number, decrement. When it is a positive number, increment. That's it. That is the formula. Got it or not? And you have a bitwise left shift and right shift operators, right? Have you heard about that? Bitwise left shift, bitwise right shift operators are there. Left shift, when you move some bits to the left side, value gets decremented. When you move some bits to the, sorry, value gets incremented. When you move some bits to the right side, value gets decremented. Got it or not? Value gets decremented. But there is a formula for this. See, if you move 2 bits from the left side, the value gets incremented. I said no. So one short formula is there. What is that? Operand by 2 to the power of n. Operand, sorry, operand into 2 to the power of n. This is the formula for left shift operator. For right shift operator, right? Operand by 2 to the power of n. These are the formula, short forms. No need to calculate that entire procedure. Forget about the procedure. You should know the procedure, but how efficiently we are answering in the interview is the matter here, right? Yes or no? Got it? No one will ask. This is not a exam, right? N can be anything. See, I just want to calculate int b is equals to 10. Okay. So if I write like this, b left shift 2. 2 is the n here. Operand means that whatever the number that we are taking here. N means what? This is number of bits to be shifted. Okay. So operand means the value. Okay. On whichever the value you are going to perform this left shift or right shift operation. N means what? Number of bits to be shifted. Number of bits to be shifted. That means if you move some bits to the left side, value gets incremented. If you move some bits to the right side, value gets decremented. For that, a big procedure is there. But I'm not following that procedure. You should know the procedure. How you got it, you understand. But forget about the procedure when you go for the interviews. Got it? This is not an academic exams, right? Isn't it? So you should apply the formula there and you should answer. Okay. The formula for that left shift is what? Operand into 2 to the power of n. Right shift operator formula is what? Operand by 2 to the power of n. Got my point or not? This is how we are also applying here the formulas. Got it? Short forms. Okay, so that means what I said here, having a separate loop doesn't make any major impact on the time complexity. So if an algorithm has n separate loops, then the loop which takes the largest time complexity, whichever the loop takes largest time complexity, that will become largest time, whichever the loop takes, that will become the time complexity of that algorithm. Is it clear? Okay, now I'll write one more algorithm. Okay, 1 minute. Let me just scroll down. I'll write one more algorithm. For that, you only tell me now. Okay, by applying our formula, no, you only tell me. So this is little variation is there here. Please observe. Okay, please observe. So I have taken a sum method. In that 2 parameters I have taken arguments. One is integer array and another one is n variable, which is the size of that array. You take 2 variables here, I variable and sum variable, because I just want to calculate the sum of all the array elements. So you start with the 1 or you start with 0. That is your wish. Okay, got my point or not? You can start with 1 or you can start with 0. That is your wish. Okay, n less than or equals to n. I1 I started. Forget about the logics, madam. Array index starts with 0, right? I am not taking all those into consideration. I'm just explaining you. If you take array index as 0, you can take I less than n here. Because I'm taking like this just for understandability purpose. I'm writing this logic here. Understand? Got it? Okay. So I wrote like this. Okay, for loop. Okay, for I1, I less than or equals to n, I plus plus sum is equals to sum plus a of I. Okay, done. Then next here you can write what? Return sum. That's it. This is the code snippet. Okay. So for this, tell me the time and space complexity now. So what is the T of X and what is S of X? Time and space complexity for this is super. Yes. O of n is the time complexity. What about the space complexity? What time complexity? O of n. Perfect. Space complexity. O of n only. Exactly. O of n only, the space complexity. How? How? Let me explain. See, first time complexity will calculate. This statement, i.e., sum is equals to 0 will occupy 1 unit of time. Plus, this loop will be repeated for n times true and 1 time false. Okay, n plus 1. And plus, this inner statement is there. No, body of the loop. Inside the body of the loop, we have the statement, right? Sum is equals to sum plus a of I. That statement will be repeated for how many times? N times. Because next time n plus 1th time it fails. No, never comes inside the loop. That is n times. Outside of the loop, this is written sum is there. No, that will occupy 1 unit of time. Yes or no? Am I going fast? Am I going fast? No, right? Are you following, right? We'll go little slower in the classroom session, no problem. Okay, please tell me. At least reply in the chat box. That is enough for me. Okay, yes, fine. Okay, fine. Fine. So this I comma sum is equals to 0 occupies 1 unit of time. Okay, now this loop will be repeated for how many times? N times. Okay, I wrote n here. One time fail, no. N 10 means loop is repeated for 10 times. 1 less than or equals to 10, 2 less than or equals to 10, 3 less than or equals to 10. Like that, 10 less than or equals to 10. True. Repeats. So n time repeats. N plus 1th time is there. No. That 1th time. Next time, 1 time. That 1 time it fails. Yes or no? And inside this statement is there. No. Sum is equals to sum plus a of I. That is repeated for how many times? N times it will be repeated, right? N times it will be repeated, right? Yes or no? N plus 1th time this fails, right? 11, I 11, no? 11 less than or equals to 10? False. It doesn't comes inside of the loop, it will comes outside. So n plus 1 plus n. This sum statement will be repeated for n times. And this written sum is there, right? That is repeated for 1 time. 1 unit of time it occupies. So total how much? 2n plus 2. Okay. Sorry, it is 2n plus 3. Okay. So this is a polynomial expression. The highest degree is what? The highest degree is what? N to the power of 1. N to the power of 1 means what? O of n. N to the power of 1 is O of n. Got it? This is the time complexity. So now S of x. Okay. S of x, space complexity. So now here it plays a vital role. Here we are taking an array. What is the array size? Earlier in the previous code snippets, we have taken only n variable, I variable, and some variable. Every variable occupies 1 unit of memory. Got it? That is what the reason in that cases we got a constant value like 3 or 4 or 5, something like that. If you get the constant value, you are representing it as O of 1, constant time algorithm. Okay, it is occupying the constant time. The space complexity is constant time. Constant space. Got it? But here it is different. Here we are taking an array. Array is of what size? N size. Understand or not? So how much memory requires? Array requires n. N locations it requires, no? Understand or not? If n is 10, 10 locations I require, no? 10 units of memories I require, no memory locations. That's why So we are taking this A array size as n. That's why n locations plus n locations for what? N unit of memories for what? For this A array. For n variable, 1 unit of memory. For I variable, 1 unit of memory. For some variable, 1 unit of memory. So this n is for what purpose? For this array purpose. Because this array size is n. N is 10. Say example, array occupies 10 memory locations. 10 units of memory spaces you require. Got it? So that's why for this array, n units of memory. For this n variable, 1 unit of memory. I variable, 1 unit of memory. Some variable, 1 unit of memory. So total n plus 3. N plus 3 means what? Highest degree is n. Okay, n to the power of 1 is the largest exponent in this polynomial expression. Largest exponent is n to the power of n to the power of 1. So that we are considering it as the time complexity. So that's why O of n is the space complexity here. Okay, understand? So here n plus 3 is the polynomial expression. The largest exponent is n to the power of n, which we are considering it as the largest degree of the polynomial expression, right? That degree we are considering it as a what you can say space complexity and time complexity here. Okay, O of n is the space complexity. No, we should count. No, we should count. Okay, now I will tell you one more code snippet. I'll tell you. Okay, with this we will wind up and then we will go for the next one. Okay, fine. I'll tell you one more. So this is tell me about this one. Okay, and here you can take it like this. I am taking a for I is equals to, you can take 1 or you can take 0. That is your wish. Okay. If you take 1, you take less than or equals to n. If you take 0, you can take less than n. Okay. And inside, yeah, please. By seeing itself, you are assuming the time and space complexity, no? By seeing the code itself. Yes or no? Got it? So some people has already typed the time and space complexity also there. I think I am seeing the chart box in the chart box. Okay, fine. Let's take this one. Okay, and I am returning like this. Tell me the time and space complexity for this. Obviously, because inner for loop you have taken. Okay, this outer for loop takes n times this repeats. Okay, so this inner for loop repeats n times. So n into n times. N into n times. Actually, this statement is repeated for n times because it is written inside this loop. But this loop is written inside the outer loop. Now, so n into n times this statement gets repeated. N into n times this statement gets repeated. Got my point or not? Actually, in inner statement I'm talking about. But actually, this loop will be repeated for n into n plus 1 time. See, this loop repeats for n times now. Plus 1 time fail, no. That fail will also be done inside this loop only, right? So obviously, what is that? Time complexity is O of n square. Space complexity is also O of n square because you are taking the 2-dimensional array. Understand or not? Sometimes no. Sometimes no. I will explain. I will explain it to you. This code snippet, I'll explain it to you. O of n square. For this code snippet, the time complexity is O of n square. The space complexity is also O of n square. I'll explain it to you. Okay. But one more small code snippet, I'll give it to you. Okay. Let me just discuss about this one and then we'll go for the next one. I'm taking void m1 method. Okay. Okay. Sometimes it looks like this. Okay, so I'm taking like this. If n modulo division 2, okay, is equals to 0. Okay, if n modulo division 2 equals to 0, then you have to print even. See, don't ask me like in Java, we don't have any print statement. I normally written, isn't it? Not related to algorithms, not related to any coding syntax. Don't consider the syntax. Here I'm just writing the code snippet. That's it. I'm not following any Java syntax or system.out.println, nothing. I'm just writing here. That's it. Okay. So if n modulo division 2 equals to 0, you print even. Else what? Else what you are doing? You are writing something. Okay. So 1 minute. Okay. Else, inside the else part, you are writing one more loop here. Okay. For I0, I less than n, I plus plus. Okay. So under this loop, you are writing something. Some statement you are writing, whatever it is. Some statements you are writing, like say example, some statement you are printing. Statement printing is there. Okay, some statement you are printing here. That's it. This is the code snippet. Now tell me the time complexity of this one. Here, the time complexity will be varied. Yeah, I'll tell you. Yeah, I will tell you. If n modulo division 2 equals to 0, here the time complexity varied. Yes, how? Let me take one example. I am taking even number as the input. N4. 4 is what here? 4 is what here? One thing you know, right? In if else, if you take if else, only one block gets executed. Is it fine? Is that fine? Yes. If you take if else, only one particular block gets executed, either if block or else block. That's it, no? That's it, no? Only one block gets executed. Okay, let us consider that I am taking a even number here. N is a even number. So 4 modulo division 2. 4 modulo division 2 what? Modulo division operator gives the remainder as the answer. If you divide 4 with 2, you will get the remainder as 0. 0 equals to 0, true. This statement is printed. Some statement you wrote, now that statement printed. What about this entire else block? Entire else block will be skipped, not executed. Entire else block will be skipped, not executed. Got my point or not? Is it clear? Yes. So here what is the time complexity? Now tell me, what is the time complexity here? Say example, if I give the negative number, if I give the even number I'm talking about. So if n is even, okay, so for executing this condition, it will occupies 1 unit of time. For printing the statement, it will occupies 1 unit of time. So total how much? 2. For executing the condition, 1 unit of time. Yes. For executing the condition execution. For executing the condition, 1 unit of time. For printing the statement, 1 unit of time. Total 2. That means what? O of 1 is the time complexity. For any even number, n can be any even number. It can be 4 or 8 or 10 or 12 or anything, whatever it is. It is occupying the same amount of memory. Sorry, same amount of time. It is occupying the same amount of time. O of 1. That is time fixed, no? Got it? Say example, if n is odd, I have taken n as 3. Now tell me the time complexity. If n is odd, that means what? 3 modulo division 2. So when you divide 3 with 2, what is the remainder? 1 is the remainder. 1 equals to 0, false. False means this statement is skipped and this else block gets executed. This statement is skipped and this else block gets executed. Yes or no? Now tell me. First it is checking for this condition, no? For that it occupies 1 unit of time. After checking this condition fails. That's why this statement is skipped. It comes to the else block, no? Inside the else block, again you wrote one more for loop. Yes or no? This for loop is repeated for how many times? N times true, one time false. N times true, one time false. Okay. Plus, inside the for loop, one statement printing, no. That statement gets printed for how many times? N times, right? That statement printed for N times, right? Are you clear? This condition will be checked 1 unit of time. If it is checked, that will fails. Print even will be skipped. It comes to the else block. In this else block, again for loop is there. This for loop repeats for N times true and one time false, N plus 1. Plus this inside the for loop, this statement you are printing, right? That is executed for N times. Yes, done. So 1 plus N plus 1 plus N. That means what? 2N plus 2, which is a polynomial expression. So the largest degree, the largest exponent will be considered as the degree of the polynomial, and that degree we are considering it as a time complexity. So here O of N is the n to the power of 1 is the largest degree, right? Largest exponent, right? Okay, we are considering it as a time complexity. O of N is the time complexity. That means here what? If the N value is even number, you are getting O of 1 time complexity. If the N value is odd number, you are getting O of N time complexity. Ma. Understand? Now, I think, Pranav, are you clear now? Pravat, sorry. Pravat, okay. So this is how, that means in all of the entire code, it is not taking the same time and space complexity sometimes. Got it? So if N is even here, it is taking one time complexity. If N is odd here, it is taking another time complexity. But now coming to this particular logic now, it is taking, because you have written nested for loops. Got my point or not? Yes. So then what exactly happens here in the nested for loops? I will tell you. Okay, we will write that so that you will understand. So first, T of X is equals to this statement I, J, sum 0 occupies 1 unit of time. This for loop repeats for how many times? Outermost for loop I'm talking about. N times true plus 1 time fail. Okay, done. Plus this innermost loop is there, no? Inner loop, J0. That loop is repeated for, I am talking about only inner loop. For J0, for J less than N, J plus plus, repeats for N times true, 1 time false. But because this J loop is written inside the I loop, this J loop will be repeated for N into N plus 1 times. Yes or no? N into N plus 1 times. Yes or no? This J loop repeats for N times true, 1 time false. Because it is written inside the outer loop, N into N plus 1 time, the loop gets repeated. Okay, na? Fine. Next one is what? This sum is equals to sum plus A of ij is there, no? So that is repeated for, because it is written inside the J loop, N times repeats. J is written inside the I loop, N times repeats. So total this sum is equals to sum plus A of ij repeats for how many times? N into N times. N into N times. Got it or not? Next, this written sum is there, no? That is repeated for 1 time. That is what the time complexity. 1 plus N plus 1 plus N into N. N square. N square I'll write like this. Cap symbol. N into 1. N plus again N square. Okay. N to the power of 2 plus 1. So that means what? Here 2 N squares are there, no? So what is the formula? 2 N square. I'm writing N square. I'm writing like that, cap N to the power of 2. Okay, 2 N square plus how many N's are there? I think 1 N here, 1 N there. 2 N plus how many ones are there? 1, 2, 3. 3. Okay, now this is a polynomial expression. Here 2 degrees are there. N to the power of 2, N to the power of N. Sorry, N to the power of 1. Okay, N to the power of 1. So which is the highest degree? Highest degree is what? highest degree is what? 2. Highest degree is 2, n to the power of 2. That we are considering it as a, n to the power of 2 is the highest degree, right? So that's why we are considering it as a O of n square is the time complexity. O of n square. Understand or not? Is it clear? Okay. The same thing applicable for space also. Because this is a two-dimensional array, no? Yes. So this will occupies n into n square. Plus this n variable occupies 1. I variable occupies 1, j variable occupies 1, some variable occupies 1. So total these are 4 variables. This is n into n because n rows, n columns. N square plus 4. Highest degree is 2. O of n square is the space complexity. So S of x is also what? O of n square. Got my point or not? Understand? So this is how it will be differed. Got it or not? Okay. Here tell me now, in this particular example, the running time complexity of an algorithm is decided by the conditional statement. Yes or no? The time complexity of this algorithm is decided by the conditional statement, right? Yes or no? See here, I am representing the, this time complexities and space complexities in 3 scenarios. One is the best case, one is the worst case, and another one is the average case. Got it or not? So what is the best case here? Generally, best and worst will take it. Yes. What is the best case here? Tell me. If n is even number, when we give the input as even number, that is the best case because the time complexity is O of 1. So when we give the input as odd number, that is the worst case time complexity because the time complexity is O of n. So this is the best case and this is the worst case. Understand? Is it clear? Fine. So this is what we discussed about little things of time complexities. Okay. So we'll discuss more about this. If you are interested, we'll go for the next session also on this time and space complexities only to discuss about the logarithmic time complexities and exponential time complexities. Okay. So we have still 3 more. N cube, when you will get it, tell me. If you write again another inner mode loop, inside this J loop, if you write K loop, you will get O of n cube, cubic. Understand or not? Okay. So here we have a logarithmic time complexity. We have an exponential time complexity also. Got it? So that one also we'll see it in the next session, and we'll go for the one of the important concept is recursion, and we have a dynamic programming also. Got it or not? So just introduction about the dynamic programming and greedy algorithms or backtracking algorithms we have, right? Different algorithms are there, right? Optimization techniques are there, right? Yes, all those things, introduction about all those things I'll provide it to you in the next session. Got it? Understand? So we have different type of algorithms like backtracking algorithms, divide and conquer algorithms, greedy algorithms, and optimization techniques we have. Okay, some optimization techniques like, this dynamic programming is there. Okay, so these are all very important algorithms that we have. Got it? And all those algorithms discussion, a little introduction about all these things, I'll explain it to you in the Monday session. Got it? I see today my team is going to create a group for us. Okay, whoever have paid now, so they'll be adding to that particular group. Okay, once it is done, I'll share all these class notes as everything in that WhatsApp group. Got it? Yes.
Syllabus, ma'am.
Yeah, syllabus also, everything I'll share there. Okay, actually, okay, they will send it to you through everyone, you people will get it through registered mail ID. Okay.
Can we expect it today?
Today, yeah, you will expect today because yesterday only I sent. Maybe by today they will be back, no? So they will send it to you to your mail IDs by afternoon. You will get it for sure. All the demo videos as well as that one also. Okay.
Thank you. Thank you.
Yeah, sure. Thank you. And that's all about the today's session. Thank you so much.